All right, so in this video, I just want to do a brief breakdown of what we learned in part 6, what we're going to be learning in part 7, sort of looking towards the exam. So in part 6, there were 4 overarching topics we covered, and I'm going to go through them in sort of most important for the exam and real life to least important. So the first of those topics was hypothesis testing. This is a huge part of the exam. It's a huge part of how statistics is used in real life. We went over the different steps for this in class, and I sort of wrote down what I would put on your note card moving through these things. So like we can just briefly break down those steps. Step 1 was setting up our hypotheses. They're always about the real deal value, the true or population, whatever it is. So that's why we use real deal P here, as opposed to P hat or P naught. We're talking about what we claim is happening in the population. We always have our equal to and our null because we have to have a place to set up our little normal distribution, some sort of mean, right? And then our alternative has a direction that's determined by the wording, right? Step 2 is finding our test statistic, which we can either do using the formula that's on our formula sheet. Oops. Or we can do by grabbing straight out of 1 prop z test. Step 3 was finding our p-value, which was all about our area under the curve given where our actual p hat ended up being, right? And this was a tail probability. It is about a probability. And this is the part that we had so many, we had that discussion board on. People have a big misunderstanding of what a p-value is. It is the probability under the null hypothesis, given this is true, it's a conditional probability of getting out our sample, of seeing our evidence. So basically our p-value is a conditional probability. What goes behind the line is our null hypothesis. So assuming that lady from our smelling Parkinson's activity is just guessing at random, assuming she has no idea and she can't actually smell Parkinson's, what's the probability that we observed what we did in our sample? What's the probability of our evidence, right? So our p hat, how does that look compared to what we thought we should have seen? So that's our p-value. And then we had our step 4, which was all about p-values low, reject the hoe. Right? Some arbitrary threshold to decide, is this probability something very unlikely? And if so, then we get to say there is enough evidence to prove that we can reject this thing that we had to initially assume, and this must actually be the case. And we write that in words. So that's our brief rundown of hypothesis testing. This is the biggest thing on the exam. You know your warm and fuzzy is going to be doing all 5 of these steps. And then I'm going to have a lot of multiple choice questions like we saw in the Kahoot and the knowledge check coming back to this. Now, how is this going to change in part 6? Well, there's only really 1 or 2 pieces where this changes when we get into part 7. Part 7 is all about means. It's all about what happens to the average. In part 6, we were looking at a categorical variable, something yes or no, right, where we had a success and a failure. For part 7, we're looking at quantitative data, so maybe how much a student spends on textbooks in a semester, or their GPA, or their score on an exam. So we are going to be using, for our value here, our mean, right, some true average. I think the true average that students scored on this exam is a 70. So that's where we're going to center our little curve. And now when we go get our evidence, instead of finding the sample proportion, we're going to be finding the sample mean. So your formula here changes up, and that is going to be on your formula sheet again. This is either Z or T. We're going to chat about this when we get into part 7, but just a heads up. There's 2 methods when we're talking about means and inference on them. There are Z methods, which use the normal, and there are T methods, which use a new distribution called the T distribution. The Z distribution requires that we have sigma, which is the population standard deviation. But The population standard deviation is calculated by taking and adding together everything and how far it differs from the mean squared. This was in our notes back in part 2. But everything you're doing in inference is trying to guess what the real mean is. So there's no way that you would actually have the real mean for this formula. So generally speaking, in real life, no one is going to be using those Z methods. And that's going to be true as well in your test. I'm not going to have a question that's like, you guys have to do a Z test. You're going to be doing the T methods. So this formula is that we figure out, again, how far is what I got from what I expected. Boom. All over our standard error. So similar to what we've been doing before. So, and then in the calculator, instead of using one prop Z test, since we're doing something with a T, we do a T test. Tail probabilities are still the same, except for now our evidence is that X bar, right, instead of the P hat, but it's still in that same assumption. 4 is exactly the same and 5 is exactly the same. So the only pieces of our hypothesis test that are changing are step 1, we're going to be talking about mu instead of P, and step 2, we're going to be finding using a different formula than we used before, or a different calculator shortcut. So the next thing we learned, or the next most important thing that we learned, was confidence intervals. Sometimes we don't have some null value. I don't think that the average on my exam is a 70, or that the average a student will score, or the average GPA of a student who's a STEM major is a certain number. So instead, I just want to know, well, what is the average that a student might have? So that's where our confidence interval comes into play. So in part 6, we had our little formula, right? There we are. And we have 2 things we're going to have to do with this. Calculate, which means just plug into the formula. Or 1, if we have a big calculator, prop Z interval instead of test. And 2, interpret. What does this interval tell us? And remember our interpretation, this is something you go in your note card. We are 90% confident that the true population proportion of whatever the heck we're talking about is between, and then your lower bound and your upper bound, right? So in part 7, same business, except for we have a new formula. Instead of using P hat, we're trying to talk about the true mean and what it looks like. So we're going to use an X bar, the sample mean, and then we're going to add and subtract. And instead of using a Z, like we said in the last one, we're going to be using T, because T methods make the most sense. And this has exactly the same pieces we saw before. Our X bar is our point estimate, right? If we want to estimate the mean, might as well use a sample to figure out what our estimate is. We have our critical value, which is how many bunny hops you want to go, except for now we're talking about steps in the T distribution as opposed to the Z distribution. And then we have this whole piece that we're multiplying by, which is our standard error, our guesstimate as to what the standard deviation is, because we don't have the true standard deviation, so we estimate it using our sample value. And our interpretation, or our calculation, we got a new formula. We also have a new, calculator shortcut. We'll be using T interval as opposed to 1 prop Z interval. And instead of making our statement about the true population proportion, it's going to be about the true mean. So that's topic number 2 that we covered. That's going to be on the exam. The third most important topic is our sampling distributions. The sampling distribution stuff is a little bit silly because it's all under this assumption that we know more stuff than we normally know in real life. But our sampling distribution, remember before, this was all about how our P hat will follow an approximate normal. When we go and roll our die, we know what we expect. We expect 50% of the time for it to come up even. We know since it's a sample, there's randomness and it's not going to be perfectly at 50% every time. So we have this approximate normal distribution centered at P with a square root of PQ over N. And this is on your formula sheet, right? Let me pull up a formula sheet so we can see it. So sampling distribution versus sample proportion. There's our mean. There's our standard deviation. And then we know that there's an approximate normal distribution because when we put all those little magnets up on the board and did those different pieces, we saw this happening, right? When I used the StatCrunch to simulate, we saw this going down. No. Now I need to remember where I was. All right. So this question on the exam, I always do is 2 steps. First step is that I will ask you to tell me what p-hat follows. You'll look through old exams, you'll see this. I'll sometimes do this as a blank, like fill in the blank. Well, I'll do this. Or a multiple choice. So it's really just about you recognizing what the heck's going on. And then the second step is always to find a probability. And for step number 2, since you know we have approximate normality, you're going to draw your normal curve centered at real P. You'll go over here to figure out what our cutoff is and what direction we care about, and then you'll use normal CDF to find that. This same thing is going to happen in part 7. Again, I'm just giving you a preview of what's coming. You could probably then go through almost everything on your own in part 7 without even watching a video. In part 7, this changes up in that our sample means, there's actually 2 different distributions the sample mean can come from. It can also come from an approximate normal, but if the original distribution is normal, our sample mean will also be normal. This was not an option over here because proportions come from a categorical distribution. So there was no way for them to have true normality. We're always missing out on those little chunks between the different bars of our graph, right? But here we can have true normality if our original distribution was normal. So if you see the word normal somewhere, you can actually use just n by itself. But otherwise, you have approximate normality. And then again, on your formula sheet, you can see we have the mean and the standard deviation for a sample mean. So you don't have to memorize anything. You just go to your formula sheet and you grab these 2 values. So I'll go ahead. I'll post this, by the way, up in the exam 3 review folder so that you guys have this like annotated version of the formula sheet if you want to like look it over. But once you got that, you're going okay. So mean standard deviation divided by the square root of n. Right? And then, so that's your step 1, and then your step 2 is exactly the same. The only thing I'll say about standard deviations, the only other type of question I like to ask is something about, well, what happens as I increase n? And it's the exact same thing as it was in part 6. As our n increases, we're going to have something that is more normal looking, provided that we had something non-normal to begin with, which has a specific thing called the central limit theorem going on in part 7. We're going to have it less spread out. It's harder to be away from average if we are taking a larger sample, and the mean will stay the same. And remember, you can see this from, that's an insane thing. You can see this in the actual equations, right? The means of all of these things have nothing to do with the sample size, but in both these calculations, you're dividing by the square root of n. So as n gets bigger, your standard deviation is going to get smaller. All right, one last topic, and then sort of an overview of miscellaneous. The last topic is sample size calculations. And this is one that's almost so small, it's kind of silly to even put by itself. So if we are given a required margin of error and a confidence level, most of the time we can figure out what our n needs to be to make our confidence interval. We have these calculations. Again, they're on the formula sheet for proportions. This is what it looks like. For means, it is z star sigma all over me squared. And then there's a 2-step process if you didn't know your standard deviation, which is the real thing. Generally speaking, pretty small in terms of importance. Probably one of these on the test. And then the 2 things you want to note is you always want to make sure you round up. even a 600.2 is going to be a 601. That way you make sure you get that margin of error. And if for this one you don't have a p-hat, you're going to use 0.5, 50%, because that's the top of the parabola. So that's something else I can test on. Other things I like to test on, duality. How do confidence intervals and hypothesis tests, how are they related to each other? If I give you a confidence interval, can you tell me if we would reject the null or not? And then errors, of course. Errors and hypothesis testing. So the next video I'm going to make is going to be a really quick one, introducing the idea of errors. And then I'll give us the beginning of 7.1 and throw you guys into all the 7.1 or the part 7 videos. But I'll probably reorganize them based on the stuff that is sort of the crucial need to know before the test, because there's a lot of them, or before week 12's meeting. But I want you to just have like the base, here's what we need.